Hello everyone, in this video I'll be explaining the problem string construction. So this video is going to be a little lengthy, so yeah, just be on the video. You will definitely understand this problem. This problem is basically trial and error. So for multiple test cases of value n and k, if we try to construct the binary string, we'll definitely get the answer. So I found a pattern. So let me first read out the problem and tell you how did I find the pattern. So you're given two integers n and k. Construct a binary string. And what is it, binary string? Binary string is a string where each character is either 0 or 1. So construct a binary string is of length n such that both of the following condition hold. Okay, the absolute difference between the number of characters 0 and the number of characters 1 in is at most 1. Okay, this is obvious, which I'll be telling you. There are exactly k pairs of adjacent equal characters in S. Formally, there are exactly k indices I, which is from 1 to n minus 1, satisfying S of I is equals to next step S of I plus 1, or determine that no such string exists. Okay, so we have got test cases. For every test case we'll have just two integers n and k, and we need to print the binary string of length n. If the string is not possible, then in that case we need to print -1. Okay, so we have a lot of test cases. We have 8 test cases, so let us take one by one. Let's go to the next page, and let me try to tell you like what the problem statement is. There will be two integers n and k. N is basically length of binary string which we need to construct. And binary string is basically string which has either 0 or 1. Their character has to be either 0 or 1. And what is k? K is basically the same. The adjacent pairs. We have to choose k indices. Choose k indices. Let the index, particular index be I, which is in the range from 1 to n minus 1. Here the string is 1 based indexing. Not well. Yeah. So you have to choose k indices such that when you're choosing the k indices, you'll have, let's say, 1, 2 up to so on, k index. Okay, in the string, it's not like you'll be having directly 1 up to n. You can have 1, 2 is skipped, you can have 3, 4, 7, 9, something like that. So basically you have to choose the k index from the string, and the index whatever you have chosen, so that element and the next element has to be equal, and there has to be exactly only k adjacent pairs of such thing. Okay, not more than that and not less than that as well. And if this is not possible, then we need to print -1. If it is possible, then we need to print the binary string, something like that. And the first condition, what they had said is number of zeros and number of ones, no difference, should be lesser than equals to 1, which means if your n is even, if n is even, in that case the difference will be 0. Why? Because you will be having equal number of zeros and equal number of ones. And if n is odd, definitely if it is odd, so one element will be more. If that element, let's say in my case I'll be taking 0 as more, so number of zeros will be more, right, than number of ones. Ones plus 1, which is basically number of zeros will be equal to number of ones plus 1. Let's say n is 5, so n is 5 and k is 2. So in that case, what could be your answer? You can have 0 1 1 0 0. If we have this as answer, right, so let's say I've chosen this, right. Now index will be 1 2 3 4 5. These are the indexes. Now if you choose basically in here k is 2, you have to choose two indices, and there are multiple ways to choose. Okay, you can choose 1 comma 2, you can choose 1 comma 3. So I'll be choosing 2 and index 4. If you choose index 2 and index 4, see index 2. Index 2 is s2 is equals to s3, right? Both are equal. And s4 is equals to s5, both are equal. And if you choose any other index, let's say s3, it is not equals to s4, which is correct. And if you choose s1, which is not equals to s2. So here the adjacent pairs are only 2. You are understanding, right? In case your n is even, let's say 8, and you need k is 4. So in that case, one possible answer could be 0 0 1 1. Let me choose k4, right? 0 0 0 0 1 1 1 1. Okay, here we're getting 6, which is not correct. We have to choose 0 0 0 1 1 1 0 1. So this is a valid, this is valid, this is valid, this is valid. Case 4. Right, see, I'm using a particular pattern, that's the reason I'm printing answer in this way. They've given answer in other way in order to just confuse the people. But yeah, I'll be explaining you how did I come to this pattern. So from the first condition you are very clear, right? The difference between number of zeros and number of 1 has to be less than or equals to 1. In case n is even, in that case the difference will be 0, because equal number of zeros and equal number of 1s are required. And in case n is odd, in that case I'll be taking zeros more and lesser number of 1s, where the condition will be number of zeros equals to number of 1s plus 1. This will be valid. Since in the question that's said the difference has to be less than or equals to 1, so this holds good. And the second, that said, we have to choose k exactly pairs. So let's take one example. How did I come up to this solution? So when n is, let's say, 7, okay, and one more case was we have to print -1 if the answer does not exist, right? So which is the case wherein we don't have any answer? Okay, this is very easy and you will definitely love it. When n is 7, at max how many adjacent pairs you can have? When n is 7, see, this is the string I'll be choosing. Because I can't choose other than that. Let's say if you choose 0 0 0 0 1 1, this is not valid because number of zeros here are 5, number of 2s are 2, number of 1s are 2, and the difference is 3, which is greater than 1, but the difference has to be less than or equals to 1. In this case, if you see, number of zeros are 4, number of 1s are 3, difference is 1, less than or equals to 1. So yeah, this is valid one. So if this solution is a valid solution, at max how much k you can have? How much k you can have? See, if you choose this index, it is equal next index. This index if you choose, next index is equal. This index if you choose, next index is equal. So these three you can choose. And if you are choosing this index, now this index, the next element is not equal. So you can't choose this index. If you choose this index, next element is equal. If you choose this index, next element is equal. And if you choose this element, you don't have any next element, so you can't choose this index. So at max, how many you can choose? At max, you can have just 5 pairs, and this is the best possible. So for this n is equal to 7, your max k will be just 5. Okay. Similarly, if you try to do n is equal to 8, what is the max k? This is a valid string, and you can't have in other way, because other will have something like, if you take, let's say here zeros are 5 and ones are 3, so difference is 2, so definitely not. But here if you see 4 minus 4, it is 0, which is lesser than 1. This is a valid one. So when n is equal to 8, how many pairs you can have? K max value. This is valid index, this is valid, this is valid, this is valid, this is valid, this is valid. These two are not valid. The reason being, next index here if you see, which is not equal. Okay, index if you take 1, 2, 3, 4, 5, 6, 7, 8. So S4 is not equals to S5. S5. Similarly, S8 is not equal as S8 we can't consider only because next element we don't have. So this is not a question at all. So at max you can have K as 6. So what you are seeing is basically max K can be found when all the zeros are together, when all the ones are together. So it is differing, the max K that you can find is differing by 2. In case of n is 5, your n is 7, your k was 5, which is differing by 2. In case of n is 8, your k is 6, which is differing by 2 again. So the case of minus 1, when it comes, when your k is greater than n minus 2, meaning you have n as 7 and k as 6, so you can't find. The reason being, for 7, this is the most optimal string you can have, and you have just these indices as valid, which is which are just 5. So 6 you can't have. So the condition is, when if k is greater than n minus 2, so in that case you need to print minus 1, right? Yeah. Now if the case is other way around, meaning if k is lesser than equals to n minus 2, so in that case we have a valid answer. Definitely we have a valid answer. If we have a valid answer, how do you find this valid answer? Again, I'll be taking example. I'll be dealing with 2 when n is 7 and when n is 8. Okay. Try to understand why I'm taking n is 7, why n is 8. N is 7 meaning we have odd, n is 8 meaning we have even. Right. Now I'll try to choose when k is equal to 0, meaning we don't need any adjacent pairs having equal. If we don't need any adjacent pairs to be equal, I'll be always starting my string with 0. Okay, so 0, we don't need any pair to be equal. If you put here 0, it is equal, so that's the reason I'm putting 1. Next, if I put 1, it is equal. So k, we have one pair, but we need k 0, we don't need any pair, so I'll be inserting this way. Okay, So this is valid string. Reason why, number of zeros are 4, number of ones are 3, difference is 1, which is lesser than equals to 1, and we don't have any adjacent pairs having equal. K is 0, that's why we don't have anything. What if we have k equals to 1? If k equals to 1, I'll choose you know 0 1 1. I'll be choosing 0 0 1 0 1 0. Why I'm doing this? Because I would have the other way around, like let's say 0 1 1 0 1 0 0. I would have done this way also. Here see, number of zeros are 4, number of ones are 3, difference is less than equals to 1. This is valid, but for k is equal to 1 it is not valid, because you have two index. This is one index and this is one index, wherein the next elements are equal. So this can be a true for k is equals to, but it is not true for k equals to 1. Okay. Now this seems to be a valid, because here there are 4 zeros, and first of all, total length of the string is 3 plus 4 is 7, and you have 4 zeros and 3 ones, so difference is 1, and which is lesser than equals to 1, which we need according to the condition 1. Okay, yeah. And k is 1, meaning we need to have just one adjacent pair having equal. So this is the one index wherein we have next element equal. If you see all other indices, they don't have next element as equal. Now if we choose k is equals to 2, what can we do is we can choose 0 0 1 1 0 1 0. Length is 7, 4 zeros, 3 ones, difference is 1, which is in valid range, and k is equal to 2, meaning we have two index whose next elements are equal, right? And if you choose other indices, these they don't have next element as equal. So let's try to draw pattern this way. We have done it for k is equal to 0, k is equal to 1, k is equal to 2. The next thing you can do is, when k is equal to 3, you can have this. See, these three indices, they have next element as equal. The other, these one, they don't have equal. And length is my 7. There are 4 zeros, 3 ones. Difference is number of zeros minus number of ones are just 1, which is within a range, and we have got 3 indices whose adjacent pair is valid. Okay, we are drawing patterns. When k is 4, what will be next? Now we do, if you are doing this thing, you have got 2 index. Now other 2 index you do it this way. These 2 you have got, and there are the length is 6, but we need 7 length. Just put one more 0. 7 length we have, and yeah, we have got 2 indices. Sorry, 4, not 2. Who is having valid adjacent pair. Now when k is equal to 5, what you are going to do is 1 2 3 4 1 1 1, and this is the max possible. 1 2 3 1 2. These are the indices where the next elements are equal, and the length is 7, number of zeros are 4, number of ones are 3, difference is 1. So what we have drawn from this is that when k is 0, you can do 0 1 0 1 0 1 0. When k is 1, starting 2 zeros you need to have, then 1 0 alternate pattern. When k is 2, you need to have 0 0 1 1, okay, and then 0 1 0 1 pattern. When k is 3, 3 zeros you need to have, 2 ones you need to have, then 0 1 0 1 pattern. When k is 4, 3 zeros, 3 ones, then remaining 0 1 0 1 pattern. When k is 5, 4 zeros, uh, three ones, and the pattern ends. For k is equal to 6, you can't find. So I've drawn a pattern for this. When n is odd, my string looks like this way. Okay, this looks to be a valid pattern, and we need to just code it. Coding also seems to be difficult, but don't worry, I'll be coding at the end as well. Similarly, you can try it for k n is equal to 9. You'll definitely get. So the pattern, I think you've got understood. Like, we need to have 0. K is 0 means this is the pattern. K is 1 means 2 zeros, then remaining 1 0 1 0 pattern. When k is 2, 2 zeros 2 1, then remaining pattern. K is 3, 3 zeros, 2 ones, then 0 1 0 pattern. And in the K4, one more 1 will be added here. So 3 zeros, 3 1, then remaining 0 1 0 pattern. Since we are starting with 0, so the clubbing of zeros and clubbing of ones after doing, we need to start with again 0. Okay, clubbing of 0, clubbing of 1, we are starting with 0. Same thing, clubbing of 0, clubbing of 1, starting with 0. And when n is equal to 8, let's try to do this. When n is equal to 8, I will find for k is equal to 0, which means we don't need any adjacent pattern. I'll start with again here 0, 0, 1, 0, 1, 0, 1, 0, 1. Wait, yeah, this is a valid one. Length is 8, number of zeros and number of ones are equal. So the difference is, difference is 0, which is lesser than equals to 1. And we don't have any adjacent pair. You can choose any index, meaning 1, 2, 3, 4, 5, 6, 7, 8, 9. Any index you can choose. Si is not equals to si plus 1, which is good for k is equal to 0. When k equals to 1, what I'll do is I'll choose 0, then I'll choose 1, 1, then I'll choose 0, 1, 0, 1, one more 0. Okay, length is 8, number of zeros are 4, number of ones are 4, difference is 0, and k is equal to 1. We have got this index when the next element is equal, and you can choose other indices. Their next elements are not equal. What if k is equal to 2? You have got a pattern now. Similarly, what you can do is 0 1 1, 0 0, 1 0, 1. Okay, so you got a pattern, right? So 4 zeros are there, 4 ones are there, difference is 0, and this index and this index serves as the next element to be equal, which is adjacent pair. Similarly, you can do it for k is equal to 3. What we need to do is we need to just extend this. So it is going to be, right, see, this index, and this index has next element as equal, and these does not have next element as equal, and we have got just 3, which is asked. K is equal to 3, length is 8, number of zeros are 4, number of ones are 4, and the difference is 0, which is lesser than equals to 1. Similarly, for k is equal to 4, what you are going to do? 0 1 1 1, 0 0 0, because these two is going to be served as k is equal to 4, and the remaining one you will have to put in, right? Yeah. When k is 5, so for n is equal to 8, I told you how do you find it. Is going k value, max k value, max k is going to be n minus 2, which is 6. So k is 5, which is valid. We will definitely get the answer. So we have 3, next it will be 4, and this is 3 only. And we don't have the length is satisfies 8, number of zeros are 4, number of ones are 4, difference is 0, and this is index, adjacent indices, and if you count this, these are 5, which is this. And here there is one trick for n is equal to 6. small one. For n is equal to 6, since this is 4 and this is 0, so what you can do is you can do all fours. I mean, when we are starting with 0, so all fours, and then we need one more 0 here, right? But since this length is 9, but your length required is 8, so this you have got extra 0. So for this special case, what when n is even and k is n minus 2, what you need to do is you need to print this way. Okay, so you have 1 2 3 4 5 6. So for n is equal to 8, k is equal to 6, this is the pattern. You can print this also like 1 1 1 1 0 0 0 0. This is also valid one. So I think for even numbers you have understood the pattern now. For even numbers, what the pattern is, k0 means I'm starting with 0, this is the thing. When k is 1, 0 will always be there, but from here 1 1 I'm choosing, then rest all will be 0 1 0 1. For k is equal to 2, this 0 will be always there, right? You will be choosing 1 1 and then 0 0, and rest will be 1 0 1 0 pattern. Because since you're always starting with 0, and you're doing a pattern with these two numbers, which is starting with 1 and then you have 2 0, so definitely the remaining elements will start with 1. Similarly, this is reserved for k is equal to 3. You have 3 zeros, then 3 ones, then 2 zeros, then the remaining. For k is equal to 4, this is reserved. You have 3 and the remaining one. For k is equal to 5, this is reserved. You have 4, okay, 4 zeros, then you have 3 zeros, the remaining you don't have any, so you can print it. Okay, so I think you guys have understood the pattern. So now in this n is equal to 8 and k is equal to 0, you will have two things, because since k is 0 and this one is already reserved, so how many numbers we are going to put now? 0 ones, so is the question, right? So this is even and this is also even. In case of even, you have equal number of zeros, so ones and equal of zeros. In case of even, you have equal number of ones, equal number of zeros. But in case of odd, you have one more than the 0 in the pattern. In case of odd, you have 3, you have 2 here, right? One more than that. So this is the pattern recognition. Some of you could try to solve this, but yeah, definitely I'll be solving in the code as well. So let's try to understand what we were saying. First case, first what we'll be doing, we'll be taking input. We'll be taking input of n and k. Okay. Next thing we'll be checking if your k is greater than n minus 2, your answer is not possible. So print answer is not possible. Now the case comes if n is even or odd. N is even. If n is even, you have a certain case. Else n is odd, you have a different case, right? Now in this, if n is even, again you have based on k. For k is even, you have a different case. Else for k is odd, you have a different case. Similarly, for n is odd, if k is even, you have a different case. Else if k is odd, you have a different case, right? But one thing you need to make sure, this one, when n is even and k is n minus 2, so in that case you need to print first continuous zeros, then continuous one, both half, right? So here is the case. Here we will be checking if n is even, we have got already. If k equals to n minus 2. So you'll be first printing n by 2 zeros, then you'll be printing n by 2 ones. Okay, yeah, so overall this looks this way. Let me just try to code, or do you want me anything to explain? I think we have got everything. So yeah, when I'm coding, we can look over this and we can solve. So let's go to VS Code. This is a big code. So okay, we have test cases. So test case I've taken up this position. For every test case I'm calling a solve function, and we're getting two integers n and k. Okay, so first thing first, we have to check if your k is greater than n minus 2. So answer is not possible. You need to print -1 and just return. Now we'll be dealing with the odd case first. If n is odd, else your n is even. N is odd here, n is even here, right? In case of even, what we have told you, we have to check k. If k is your n minus 2, which means the maximum possible k, so in that case you need to print half zeros and half ones. Okay, we are printing half zeros and half ones, right? And at the end, don't forget end l. Okay, so even case we are dealing first. We have done this now. Let's go to iPad and see n is even case, and when your k was even. Okay, when your n is even and k is also even. Here k is also even. You have got how many both first you need to display 0, and then you need to display equal number of zeros and ones, and we have 3 here. So how can we find it? You can do is k by 2. The reason being, see, k here it is 4, right? You need 4 pairs. 4 pairs if you need, so it means we are dividing equally in zeros and ones, so 2 should come from here and 2 should come from here. So that's the reason we are doing k by 2, and k by 2 it is going to be 4 by 2, which is 2, right? Okay, so okay, if this is the case, understood, right? See, if k is n minus 2, we are doing this. Else we have to check here again. If k is odd, where we have other case. If it is even, we have other case. For both odd and even, first we need to print 0. So 0 I'll be printing, and I'll be taking one done variable as 0, which means this many strings we have done. Okay, so let me take one variable as done, which means right now we have not created a string, so the string length is 0. It's like created string length. Okay, so 0 we have displayed, which means one string, I mean the length of the string is 1, so done plus plus will be. And as I said, in case of n is being even and k is being even, your count is going to be k by 2. So you'll have to check if this count is greater than 0. Okay, Why we are checking this count greater than 0? Because if you see a case of k being 0, right? K being 0 means your count is going to be 0 by 2, which is 0. So in that case you don't need to print anything. Okay, I mean equal zeros you don't need to print. Okay, k when it is 2, 2 by 2 it is 1, so you will be printing just 1. Okay, and this last one will be printed in a different way. So we need to definitely check. Okay. So here your count you have got, while count you will be printing, first you will be printing 1 here, right, in case of n being even and k being even, and you're done plus plus. So k by 2 times you have printed, and the next value is going to be 1. Understood, right? See, when k is even, n is even and k is also even, you will be printing two indices wherein you have, the next element as equal. So for this two elements you have done it. For this element, the next element this. Since you have created 2 and last elements, the next element has to be equal, right? That's the reason we are doing at last this thing. Okay. And now one more variable I take last used, it is 1. Last used, I'm taking one variable. It is basically telling you like what all we have constructed till now. Let me use again. Battery is low. Yeah. So last use is basically telling you when we are constructing these patterns, right? When we are constructing these patterns, what last element we used in order to make sure the other patterns we are creating. Let's say when k is 0, right? Let's say when k is 1. So you'll be printing this 1 1, let's say. Okay. It is going to come in case of k is equal to 1, where you'll be having count as, count will be k by 2 plus 1 it will be. So it is going to be 1 by 2 is 0 plus 1 is again 1, which means 1 you will be printing and next you will be printing. But since the count of zeros will be just k by 2, so in that case we don't need to print. Okay, we don't need to print this. So for that reason I'll be taking last. Initially I'll be just initializing with 1. The reason why I'm telling is because my string is starting, the first element of the string is 0, which means previously I would have used 1. It is just saying that way. So here your last use will be 1. Okay. Yeah. And now again your count here, it is going to be k by 2 because it's case of even. So next you'll be printing just 0. Yeah, now again cout 0, done plus plus, and your last used will be here, last you have used 0. Now since these many length of string you have already created, the remaining string length is going to be n minus equals to done plus 1, you can say, minus equal to done. It's like you have n, you need to print n characters. So these many you have done, and remaining are n minus 10. And now we'll take one variable bool which is 0. Initially we can set it as let it be this way. We need to check if last used is 0. If last used 0, then we need to use next element as 1, because for the remaining we are printing, right? It's like when case 4, these things we have done. Last use we were 0, so for the remaining one we have to start with 1. For the remaining, we're starting with 1, which means we need to have false, and initially we'll be taking it as 2, right? And we can say while n minus minus if 0, then we need to print 0, else we need to print 1. It is just taking alternate. How do we print the alternate 0 and 1? And we have to negate the 0 here. Okay, this is done. Now when n is even, and here k is even, here k is odd. In case of odd, what we are doing, k by 2 plus 1 will be printing. See here, in case of odd, which means we need 3 adjacent pairs. So in order to print 3, so somewhere like either 0 or either 1 has to print more adjacent pairs, right? So in our case we'll be printing for 1. So if you do k by 2, which is going to be 3 by 2, which is going to be 1, but we want 3 numbers, so we need 2 adjacent pairs. So we will be doing k by 2 plus 1. Okay, yeah. Again we need to check here if count, because in case of k being 1, you need to just print this thing, and here this one will not be printing, and the last use variable will take care of all the things. Yeah. While count minus minus, we need to print 1, and your done will be like yeah, right? Now when you're printing zeros, continuous zeros, it will be k by 2 just. If count, and don't forget here last used is going to be 1, and here also don't forget, here last use will be 0. Last use will be 0. Now your n, the remaining length of the string is this. Now again we'll take one bool variable. If last used is 0, then we need to use next as 1, right? So for that case 0 is false. Initially it will be true. Similarly we have done it, right? Yeah, we have done it here that way. Now these two cases are done. It's just a case, guys, like n being even and k being even, n being odd, k being odd, that way. So for n being even, we have dealt with both the cases. K is odd, k is even, and one more was when k is n minus 2. Now when n is odd, so we are taking case of n is odd. let's choose this one. When n is odd, k being even will take. N is odd if k is, this is k is odd. Else here k is even. Yeah. So when n is odd and k is even, let's take this one, right? So what do we have? We have continue. It's like, see, we need k adjacent pairs, so we will divide equally in both zeros and ones. So 2 will be here and 2 will be here. So 2 zeros will be printing, and at the end we need definitely 1 in order to make sure the last 0 is a valid adjacent one. Similarly, we will do it for here. So what we are doing, just count about 2. We are doing right. Yeah. Your count is going to be k by 2. If count I think you have understood the pattern. Just we are solving in a way. Thus it will take time in order to grasp. So in case of n being odd, we are always starting with 0 first, right? Yeah. And in order to make sure the last 0 is a valid, so we have to print one more 0. And here last used is going to be 0. Okay. And now we need to print similarly once. And last used is going to be 1. When we are done with this printing of zeros and continuous zeros and 1, the reason we are checking if count, I will tell you one more time. I've been telling, but let me tell you one more time. This was the case of n is odd and k is even, right? So here k by 2 is going to give you 0 by 2, which is 0. So you don't need to print anything. You need to just print the 0101 sequence. And that's the reason if it is 0, we are not printing anything. If we print, so the extra zeros will be printing here, right? So yeah. And your remaining length will be done. We'll take bool 0 here. We have to check if last is equals to 1, because in case of n being odd, we are starting like 0 0 0 0 1 1 1 this way, right? So when we are doing it this way, so we have got a 0 1 sequence, next will be 0. So last use, if it is 1, so the next element that will be chosen is 0. So initially I do it false. You have to check if 0, we need to print 0, else we need to print 1 and just negate the 0. Okay, here also we have missed it. Same thing we'll be doing. Yes. Now n is odd and k is also odd. n is odd and k is also odd. In that case, what you're seeing is unequal number of pattern. 3 zeros, 2 zeros, then remaining 0 1 sequence. So here it will be how many zeros will be printing? It is k by 2 plus 1. Starting this many zeros will be printing, and k by 2 ones will be printing, right? So 3 by 2 is 1 plus 1 is 2. So 2 zeros will be printing, and for last 0, this is the counter 0. And for even case, we will be printing k by 2 just, which is 3 by 2, which is 1. So 1 will be printing, and this one to make adjacent, next one will be printing, and the remaining 0 1 sequence, which can be done using this last use variable. So count is going to be k by 2 plus 1. If count, I think when you understood like n being even odd and k being even odd, the remaining can be done easily. So in case of n odd, we are printing first odd as a 0. Last two is 0. Now when you are printing number of ones, it is going to be k by 2 just. And last use is going to be 1. Now your n is going to be done, while n minus minus, we have to take care of zeros as well. You have to check if last used is 1, so the next you'll be using a 0 for the remaining string. So yeah, initialize with false. If 0, you are printing 0, else you'll be printing 1, and let's negate with 0. Done. I think this is done. Let's try to run the code. Oops. Compilation on 129th. Mm-mm. 129, right? What did the error say? Count previously declared. Where did we declare? We have declared in this. So what can I do? We can remove this basically, yeah. Okay, Control C, let's do. Okay, here we can do is and return, and this else can be removed. Basically, what you're doing is, in case of n1 and k being n minus 2, we'll be doing a special case and just return. And if it is not a special case, so we are dealing with this k being even, k being odd. So 141, sorry, 141. Okay, here, my bad. Okay, guys, I think the pattern what we have chosen is that pattern, but what they're expecting is they're expecting this one in a test case, which is also valid, but our case is also valid. If you see, k is 2, right? Okay, length should be 5, k is 2. Our length is 5, k is 2, which is correct. This is the index, and this is the index. And for minus 1, wherein the answer is not possible, yeah, we have also answer is not possible. Similarly here, similarly here. Okay. For 6-1 case, answer has to be 1 we need, right? So we have got 1, just 1 here. And for k0, yeah, we don't have any adjacent pairs. For 3, we have 3, right? See, 1, 2, and this one is 3. So this, if you going to submit in the yeah, we can try it out here. String construction. Yeah, it got accepted. So this was a bit of I feel hard problem, but yeah, we can do it anyway. I think main the thing was like understanding a problem statement. Once you understand the problem statement, definitely you can follow the code as well. Code seems to be a bit of confusing, but yeah, once you follow the explanation, you'll definitely understand. And if you don't understand, try to watch out the video one more time. And yeah, if we try to understand the time and space complexity, it is going to be O of n only, because the loops whatever we are using, basically we are constructing here the string, right? So whose length is n, so it is going to be O of n, and space is constant. We are not using any vector or something like that. So yeah, thank you guys for watching the video.